we're going to discuss the derivation of half-angle formulas. But before we do that, we're going to have some review on the formulas that we're using for the double angles. No? So we start with sine 2 alpha. That will be equal to 2 sine alpha cosine alpha. No? These are all double angle formulas. For cosine 2 alpha, that is equal to cosine squared alpha minus sine squared alpha. So we're going to modify this one. No? This sine squared alpha is equal to 1 minus cosine squared alpha. So if we want to get rid of this one, the result will be, so this one will become negative 1, and this one will become positive cosine squared alpha. So cosine squared alpha plus cosine squared alpha is equal to 2 cosine squared alpha minus 1. So we're going to call this one equation 1. And we're going to use this in the derivation of half-angle formulas. So we go back to cosine squared alpha. For this cosine 2 alpha, this cosine squared alpha is equal to 1 minus sine squared alpha. And this one we just copy, minus sine squared alpha. And if you will notice, negative sine squared alpha minus sine squared alpha is equal to 2 sine squared alpha. So this 1 minus 2 sine squared alpha, we call this one equation 2. So we now have two identities or formulas for cosine 2 alpha. And we call that equation 1 and equation 2. So tangent 2 alpha is equal to 2 tangent alpha over 1 minus tangent squared alpha. So we're going to focus on equation 1 and equation 2. From equation 1, no, if you will notice, if you want to get the value of 2 cosine squared alpha, we just transpose this negative 1 to the other side of the equation. So this negative 1 become positive. So this one is 2 cosine squared alpha. That will be equal to positive 1, the one that we have transposed, plus cosine 2 alpha. And we now call this our equation 3. For equation 2, cosine 2 alpha is equal to 1 minus 2 sine squared alpha. So we want to transpose 2 sine squared alpha to the left side of the equation. So 2 sine squared alpha is equal to 1 minus cosine 2 alpha. And we now have two equations, 3 and 4, from equation 1 and 2. So this one is 3 and 4. In equation 3 and 4, if you will notice, this alpha here is twice this 2 alpha. So make this to make this one distinct, we let 2 alpha to become theta. So alpha will now be equal to 1 half theta. So if we substitute these values here to equation 3 and 4, so we now have 2 cosine theta over 2 for the value of alpha, no? So 2 cosine squared theta over 2 is equal to 1 plus cosine theta. And cosine squared theta over 2, just divide both sides of the equation by 2. And we have 1 plus 2 cosine theta. We now have a half-angle formula for cosine. For 2 sine squared theta over 2 is equal to 1 minus cosine theta. You just divide both sides of the equation by 2. And that will be equal to sine squared theta over 2 is equal to 1 minus cosine theta over 2. And we now have another half-angle formula for sine, no? For tangent squared theta, no? We just that value is equal to sine theta over 2 over cosine theta over 2. So that is equal to 1 minus cosine theta over 2 over 1 plus cosine theta over 2 over 2, no? All over 2. So we just cancel 2 here. What will remain is equal to 1 minus cosine theta over 1 plus cosine theta over 2. So, sine theta over 2, the half angle formula, no, as we have derived, no, from this one, no, sine theta over 2. This one is sine squared, so we divide, we just get the square root of both sides of the equation. So, we will now get the half angle formula, sine theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 2. Similarly, for the cosine theta over 2, we have derived, we just get the square root of both sides of the equation. We get 1 positive or negative square root of 1 plus cosine theta over 2. So this one is also another half angle formula for cosine theta over 2. For tangent theta over 2, we will get plus or minus square root of 1 minus cosine theta over 1 plus cosine theta. So we will apply the half angle formula in proving the identity. So we have to prove the identity. Sine squared a over 2, a will be another angle, is equal to secant a minus 1 all over 2 secant a. So to solve this kind of identity, we work on the right side of the equation, since this is more complex than the left side. So we write this as secant a minus 1 over 2 secant a. And that will be equal to, so secant a is equal to 1 over cosine a. The reciprocal function of secant a is equal to 1 minus 1 over cosine a minus 1 all over 2 times quantity 1 over cosine a. So, excuse me. So, as you can see, we can cancel out this cosine a and cosine a here. What will remain is 1 minus cosine a over 2. So, this will be our answer. 1 minus cosine a over 2. Now, this 1 minus cosine a over 2 is equal to sine squared a over 2, as we have derived for our half angle formula. So if we will compare our sine theta over 2, the half angle is equal to 1 minus square root of 1 minus cosine theta over 2. If we square both sides of the equation, we will get this one also. No? So 1 minus cosine a over 2 is equal to sine squared a over 2. So we are successfully proven that this 1 minus cosine a over 2 is equal to the given sine squared a over 2. So that's it. This will be our answer. So thank you again for watching our videos for today. Please don't forget to subscribe to my YouTube channel by Wilfredo, and also click that notification icon. If you have some suggestions or comment, please do so. Send it to us so as we can improve our method of presentation. And also, thank you for watching again, and see you again later. Bye-bye.